Plant charge balance is a scientific fact. Nutrients are charged. You buy a fertilizer because it either carries a positive charge or a negative charge. As a quick example, nitrate nitrogen carries a negative charge. All nutrients that a plant takes up carry a charge. A scientific fact about that charge is a plant must have 50% positive and 50% negative charge in its overall makeup. In agriculture, we don't view that currently. We talk about pounds per acre. The goal of Redox Bionutrients is we still will talk about pounds per acre, but we will also talk about plant charge balance. How is the nutritional program that you are using, how are the agronomic practices that you are implementing contributing to the ability of the plant to balance its charge? Because here's one more scientific fact. If that plant gets out of balance, it will stop doing everything else. It will stop making kernels of corn. It will stop making flowers on the tree. It will stop producing potatoes on the plant to balance that 50-50 charge. That energy has to come from somewhere. Sometimes our fertility practices, sometimes our agronomic practices create that imbalance. And so the goal of Redox Bionutrients, the product line of Redox Bionutrients, is focused on quickly correcting that plant charge balance and the education of how to implement proper agronomic practices and fertility programs that do not contribute to that imbalance that often occurs in a plant. Because a plant must balance its charge, 50% positive and 50% negative. So you will hear from Redox Bionutrients going forward a constant conversation about plant charge balance and how the nutritional programs, how the agronomic practices you are doing contribute or detract from the ability of that plant to create its own balance. So I get asked a lot, what goes into product formulation? What do you think about in product formulation? Well, we obviously think about the end result. I'm trying to affect a physiological process in the plant or a physiological process in the soil. Once we determine what that process we want to affect is, we go to work and we start to look at processes and how to influence those processes. Assuming we get to product formulation, there are 5 considerations in a product formulation, okay? One is movement, the next is absorption, the next is translocation, the next is metabolism, and the last is utilization. Let me go through each one of those very quickly. Product movement. Just because I spray something on the soil or put it on the soil, my job isn't done. That product has to be mobile so it can get from point of application into the soil water system and into the plant root. That's not an automatic. Things become tied up in the soil very, very easily. So part of product formulation for Redox Bionutrients is putting additives, natural additives into our products that allow them to more easily move in the soil water solution. Once I get them to move in the soil water solution, they come to the root, and there's that root interface. I have to be able to breach that root interface and get my product through that root interface without causing harm to the plant, without taking energy from the plant. It needs to be a natural process. That's the next consideration in our product formulation, or what additives can I put in my product that'll help in nutrient absorption to the root or to the leaf. People will then think sometimes, well, man, once I get it into the plant, my job is done. No, because now I've got to go take it from point of entry into the plant to point of need into the plant. That's translocation. My product has to be able to be translocated. What, if any, additives are necessary in my material that aid in product translocation inside of the plant? That's part of our product formulation. Then once I get it to that point, all of these additives I put into my product cannot detract from the ability of that plant to utilize that material. Have I gummed up the system so much that the plant can't utilize what I'm trying to do? All of that has to be taken into consideration. Then once we're done with the metabolic portion of creating a compound with my nutrient or my product additive, it has to be able to be utilized by the plant. That means it has energy value to the plant. Why is that of concern? Because if what I'm putting on requires excessive energy by the plant to do all of these functions, I really haven't contributed to plant metabolism or crop production. I want to be an energy contributor to the plant, not an energy detractor. And oftentimes the fertilizer programs that we employ require a lot of energy from the plant to do these processes. We, in our product formulations, create positive net energy to the plant when we put our products on. At Redox Bionutrients, we focus on redox active substrates. That is a scientific term. What are redox active substrates? They are compounds that can absorb a charge or can give off a charge. So if we go back to our lesson about plant charge balance, a plant has 50% positive and 50% negative. What happens when that gets out of balance? I need something that can contribute to or can absorb the necessary charge. That is what a redox active substrate does. And the additives in the product line of Redox Bionutrients contain, as part, redox active substrates to help the plant in that plant charge balance. What if we don't do that? Well, if we don't do that, the plant will, and it will rob energy from growth to be able to balance itself by creating its own redox active substrates. We are simply providing that for it, recognizing the need to balance charge in a plant so that plant energetic process can move forward and grow better. For example, in turf, how do I get a thicker leaf blade? How do I get ball recovery better? How do I grow a better root system to be more drought tolerant or more environmentally tolerant to changes in temperature or weather? We do that by creating these redox active substrates, adding them to the plant, and therefore now my plant has more energy to conduct its natural processes without robbing from them to balance itself nutritionally. That's incredibly important. It's a completely new way of thinking about fertilizer and about plant nutrition, is on a charge basis rather than on a pounds per acre basis. But it is incredibly important that we start thinking that way to create a more sustainable agronomic system. I want to emphasize or talk about some product manufacturing processes that are incredibly important here at Redox. One of the things we do at Redox is we start our additives from natural sources, from protein sources, from plant sources, from existing sources such as leonardite, etc. Those are very large, complex molecules. So one of the first things that we do is we go through a process called fractionation. That is where we take that very large organic molecule and we break it down into smaller components. And we spent years studying what we want those components to look like, and we do it by size and shape, okay? And when we do that, we're able to more specifically hone the response that those molecules give us when applied to a soil or to a plant. So taking complex molecules and breaking them down into more important components is one of the things we do here at Redox, so we can be much more focused in the desired soil or plant response that we want. Then we take those molecules and, for example, we'll do something called chelation. That's a common term, where we help the molecule in question, let's say iron, for example. We chelate that iron product so that it goes into the soil and is able to move through the soil and into the plant better, okay? That's a process that we are very capable of doing, and we're very focused on. Complexing takes a negatively charged molecule like phosphorus, and it surrounds the molecule so that it doesn't tie up in the soil and it's able to move through the soil and into the plant better. That all starts with this fractionation process, and then we, in our manufacturing process through heat and pressure and temperature and a whole bunch of things, put these products together in that form. Another process that we use is called microencapsulation, where we take some very difficult to move molecules and we literally, in a surfactant, pressure them into a surfactant so that they're part of the surfactant molecule. That allows them to move in the soil better and move in the plant better. Because again, movement of products is incredibly important. So those are some of the processes that we go through in our product formulation that are incredibly important to Redox, incredibly important to our formulation, and are the reasons why we're able to get by with such small use rates, is because we are highly specific. We're not just throwing a bunch of organic matter into a tank and hoping that it comes out well in the end. we know what we're putting in the tank, we know what we're pulling out of the tank, and we know what process we want to influence with those molecules.